So we want to see how we can tune the connection between a switch in an MST region and the ones in a non-MST region. So over here, this topology, we see that all these 5 switches here are in an MST region. So how can they interoperate with this switch here? Okay, let's look at the question. Now the question is requiring us to run VTP on the network. So let's take it one after the other. 1, run VTP on this network by making switch 9 the VTP server and the rest of the switches as VTP clients. So after doing that, you create 3 VLANs, VLAN 10, 20, and 30. No, 4 rather, sorry. VLANs 10, 20, 30, and 40 on all the switches. So let's take it one after the other. Let me capture. So what we are going to do is a minute, please. Let's connect my writing pad. All right, so on this switch here, we are going to convert it to a VTP server. We'll create VLANs 10, 20, 30, and 40 on it. I'll let this port here access VLAN 10 and this port access VLAN 20. After that, all these ports are going to be converted into trunks. So that is the first step of configuration. All these ports are going to be trunk ports. So let's do it. So I'm on switch 9. Let's name it. VTP mode server. Switches are all on a server mode by default. So this device is already in the VTP server mode. There wasn't the need for that configuration. Now let's convert the other switches as VTP client. But before we do that, let me create the trunk ports on switch 9. So interface range E 0/0, comma E 0/1, switch port mode trunk. Okay, so I think this is a layer 3 switch. So we first of all have to enable the trunk encapsulation. Switch port trunk encapsulation .1Q before we enter switch port mode trunk. Okay, so that's fine. Let me save. Then we go to switch 5. Enable host name SW5. VTP mode client. Let's create the trunk ports. Interface range E02, E01, and E00. Switch port trunk encapsulation .1Q. Then switch port mode trunk. Let me save. Switch 15. Host name SW15. VTP mode client. Interface range E03, zero zero 02 and E01. Yeah. So switch port trunk encapsulation .1Q. Switch port mode trunk. Here. Host name switch 10. VTP mode client. I created the trunk ports, so interface range E00, E01 and E02. Switch port trunk encapsulation .1Q. Switch port mode trunk. Let's come to switch 14. Enable configure terminal and a host name SW14. VTP mode client. Interface range E0/0, E03, and E02. The last switch, switch number 18. VTP mode client. E01 and E00. Sorry. switch port trunk encapsulation. .1Q and switch port mode trunk. So let me go to the server to create those VLANs, but I have to create a VTP domain. So the server is the switch 9. Let me create a VTP domain. VTP domain. Let's call it AfriLink. So we have created a domain name as AfriLink. All right. VLAN 10. VLAN 20. And VLAN 30. Sorry, VLAN 40. Show VLAN. Let's verify whether all VLANs are created. So they are here. Let's check from this switch to see whether it's receiving the VLAN. So switch 18. So VLAN. Right, so all the VLANs are appearing. I'm sure they are appearing on the intermediate switches. So I think question 1 is done. We've been able to create VTP and also configured all these VLANs on the entire network, both on the MST domain and the non-MST domain. So question 2 says, configure the switches in the MST region with the name lab_01 and with the revision number of 6783. Also in the MST region, configure 2 MST instances, that's MST1, which will have all these VLANs under it, 10 and 30, and MST2, which will have VLAN 20 and 40 under it. So let's do that. So I'm going to do that on only the switches inside this domain. All right, switch 5 first. Exit. All right, so spanning tree, we have to first of all enable MST first. So let's see how the configuration goes for that. Spanning tree mode, MST. Then spanning tree, MST configuration. You enter, so that's where you're going to enter the name and the revision number. So according to the question, let's view it once again. Which name should we give to the MST instance? lab_1 with a revision of 6783. Yeah, switch 5. Name lab_01. Vision 6783. Six, 7, 8, 3. What next? Here we have to create the instances. Instance 1. And the VLANs under instance 1 are VLAN 10 and 30. Instance 2, we have VLANs 20 and 40. So a little verification. Let's show spanning tree. MST config. And here we have MST instance 1. Another instance 1, we have VLANs 10 and 30. And also for MST instance 2, we have 20 and 40. And take note, this is the internal STP, which has all other VLANs under it. This one is the default instance which is created whenever you enable MST on your switches. And this command, we have to do the same command on all the switches inside of the MST region. So let's do some copy and paste. All right, let me do some copy and paste. Call a notepad. So I'll copy this and paste on all the other switches in the MST region. So we come to switch 10. Paste. Okay. Show spanning tree, MST config. Oh, we didn't enable the spanning tree mode. Let me check the notepad once again. We did. Check once again. Let me paste the configuration again. Config T, spanning tree mode. Copy. We made a mistake here. I have to take off all the asterisks, the hash. So copy. And paste. right thing has been done. Show spanning tree, MST configuration. So we have created a MST on the switch. We can see the internal MST there, MST0. Switch 15. Let me paste. Okay. Paste. And show spanning tree, MST configuration. So we have it there, 14, switch 14. The last one, switch 18. So we have successfully configured STP MST, multiple spanning tree, in this region. All these switches are running multiple spanning tree. Let's go over the question again. So configure the switches in the MST region with this name, which we have done. Okay, so we have done this part of the question. Now let's determine the root bridge. Here we want to determine the root bridge for the IST instance. We want to determine the root bridge for the IST instance. So in determining the root bridge for the MST, we issue this command. First, let's issue show spanning tree root. And this output is showing us that for the MST0, that is the IST, the internal MST, this bridge or the switch with this MAC address is the root. And for MST1, the root is this switch and MST2. So what we realize here is one particular switch is the root for all the 3 instances. One particular bridge is the root for all the MST instances. So let's look out for that switch. Let's look out for that switch. And the command is show spanning tree, MST. So for MST instance 0, we are on the switch 15. That is the MAC address of the root bridge. This is the MAC address of the switch that we are on. And these are the root parameters. So that is on the root. That is on the root. Let's look out for different switch. So on switch 5, show spanning tree, MST. And for MST instance 0, what do we see? This switch is the root for this MST. That is the root. This is the root. So for MST 0, switch 5 is the root. Let's go down. And what do we see here? MST 1, that same switch is the root. So one particular switch has become the root for all the MST instances. MST is a good thing, but this is going to cause imbalance in the network if we leave it at the default settings. So we should be able to tune the settings. So question 3 is captured. The root bridge for the IST, which is also the default MST, is this switch here, this one. Okay, let's move on to the next question. Now we're going to make switch 10 the root for MST1 and switch 15 the root for MST2. On switch 9, we should run per valence spanning tree. So switch 1, switch 9, this switch here is not going to run MST. Okay, so let's quickly run the rapid per valence spanning tree on it before we forget. Enable spanning tree mode. So this is the option that we want. This one. Did it say rapid per valence? Let's check. Okay. A02.1W, so that's the rapid per valence spanning tree. So rapid, save it. What's the other part of the question? We are going to make switch 10 the root for MST1 and switch 15 the root for MST2. So this is switch 10. Here, this one here is going to be the root for MST instance 1, and switch 15, this will be the root for MST2. Okay, so let's do the configs. Now switch 10. Configure terminal. Spanning tree. For MST1 root primary. Done. And we come on to switch 15. Spanning tree for MST2 root primary. All right, so question Question 4 is done. Now we have to ensure that the PC, VPC1 and VPC3 use path A, whilst VPC2 and 4 use path B. So let's pick the capture once again. That is VPC1 in VLAN 10, and VPC3 is also in VLAN 10, and that is the path A. The path should go through this link, come here, and go there. That's the path A. And VPC2 in VLAN 20 should also use path B to communicate with VPC4. That is path B. But as we all saw from the tutorials, this switch in the non-MST region is going to receive BPDUs from both switches in the MST region. And all of them are going to advertise this interface here with a port cost of 0. So that's what this switch is going to inform the switch 9. Same way, switch 15 is going to inform switch 9 that the port cost on this interface here is 0. That is what happens if switches in a MST region communicate with switches in a non-MST region. So now the switch here has to make a decision as to which port will be its root port. So what is the tiebreaker? The tiebreaker will be the lowest MAC address. So is it this one or that? The switch with the lowest MAC address will be chosen. So supposing switch 5 has a lower MAC address compared to switch 15, then this switch 9 here is going to use this link here as its root port. And one interesting thing is that will be the root port for both VLAN 10 and VLAN 20. Okay, what the root bridge that this switch inside of a non-MST region sees, this switch will see the root bridges, those root bridges as coming from the same VLAN, even though we have configured this switch as the root for MST1 and this switch as the root for MST2. But this switch, however, continues to be the root for MST0, the default one, root for MST0. So interestingly, this switch here is actually going to see switch 5 as the root for all the VLANs, for both MST1, MST2, and MST0. It's not going to identify all these switches here. So let's see some verifications. Before we do the verifications, let's configure IP addresses on the PCs. So for VPC 1, we are going to assign, we are choosing the IP from this VLAN here, VLAN 10. So we are assigning 10.10.10.10 on it. So let's save. We come to VPC 2 in the VLAN 20 network. So we give it an IP of, there's no need for a default gateway here. IP 10.10.20.10. It's a /24. So let's save. Then this PC also in the VLAN 10. Let's assign 10.10.10.30. So IP 10.10.10.30 /24. Save. So this one will also be 10, 10, 20, and 20. /24. Save. At this moment, we want to determine the path where VLAN 10 traffic is using, as well as VLAN 20 traffic. So for the VLAN 10, for this PC to communicate with this PC, when the packet gets on switch 9, it has two choices to make. Will it go here? Will it go there? So let's check the VLAN 10 parameters, whether the traffic is forwarding here or forwarding here, and we'll see where the port is also blocking for VLAN 10. So on switch 9, let's show this command. Show spanning tree for VLAN 10. And what do we see here? Ethernet 00 is the root for VLAN 10, and that port is forwarding. But we can see E01 blocking for VLAN 10. So no VLAN 10 traffic is using this link. VLAN 10 is forwarding on this link. So we can see that VLAN 10 is going towards this switch. What happens if the traffic gets to switch 5? Let's show the command to see. Our task is to ensure that VLAN 10 traffic use this link we are seeing here to communicate with each other, and also VLAN 20 traffic will also use that link to communicate. That is our task. So we are only verifying where VLAN 10 traffic is using currently. So on switch 5, let's see the path for VLAN 10. We're on switch 5 here. And the command is show spanning tree for VLAN 10. Okay, so switch 5 says E00 is the root and is forwarding VLAN 10 traffic. So the VLAN 10 is going towards E00 on switch 5. Where is switch 5? Yeah. So VLAN 10 goes here, and when it gets to switch 5, it goes on E00, VLAN 10, heading towards switch 10. So what happens if the packet gets here? We go on switch 10 to issue a similar command for VLAN 10. Switch 10. Yeah. Now we are determining the current path for VLAN 10. Show spanning tree for VLAN 10. And that is the root bridge for VLAN 10. So we'll find all the ports forwarding traffic for VLAN 10, which is normal. All the ports are forwarding for VLAN 10 because that is the root for VLAN 10. Remember, VLAN 10 is in MST1. So this is normal. Now, if it's forwarding, we come to switch 14 to see which ports are blocking for VLAN 10. So 14 and show spanning tree for VLAN 10. On switch 14, E0/1 is the root bridge for VLAN 10. So we are very sure that VLAN 10 traffic is again using this link here. Okay, meaning the packet, when it gets here, it will definitely descend down. So we're on the right path. What happens on switch 14? So currently, we are very sure that VLAN 10 goes here, comes here, and descends down. So we are now on switch 14. Let's see where the VLAN traffic will go. All right, so VLAN 14, aside the fact that E0/1 is a root, all these other ports are also forwarding VLAN 10. Fine. So we come to switch 18. So when the packet gets on this switch 14, from our output right now, it shows that the packet can either go through this port or go through this port. But will they be accepted on this port here? So let's check on switch 18 to see where the traffic will be accepted. switch 18, show spanning tree for VLAN 10. So switch 18 is blocking VLAN 10 on E0/1. VLAN 10 is not going on E0/1, it's rather going on E0/0. So there's a problem here. Instead of the traffic to go through E0/3 towards E0/1, we are told that the traffic is blocking VLAN 10 here. So VLAN 10 is not going on this link. Instead, it's going on this link, which is not accepted. Our task is to enable VLAN 10 to go through this interface. Currently, E01 is blocking. So what do we do? And if you look at the question, the down part of the question says, do not modify any port host on switch 18. So we are not supposed to modify any port host. If we are allowed to modify a port host on switch 18, then we can come on switch 18 and make this port here attractive for VLAN 10 by lowering the port host. But we cannot do that. Don't worry. We can do that configuration on this port here, on port 14. We can lower the port priority on this port on switch 14. That will make it attractive for VLAN 10 to use this link. So once we lower the port priority on E0/3, we'll see that this port here will open for VLAN 10. So let's check the current port priority on the switch 14 first. On switch 14, let's show spanning tree for VLAN 10. Concerning Ethernet 0/3, the port priority is 128.4. This is very big. I think that is what is making the port unattractive for it to enter this interface. Yeah. Okay, because of the high priority on this port, that is why switch 18 is blocking VLAN 10 here. So we are going to reduce this port priority for VLAN 10 to 32. And we'll see that this port here on switch 18 will be open. Currently, it's blocking. Let's verify once again. Switch 18. Show spanning tree for VLAN 10. And E00 is blocking all the VLAN 10. E0/1. Sorry, E0/1 is blocking the VLAN 10 traffic. So we want it to follow the VLAN 10 traffic by lowering the port cost on switch 14. Okay, so on switch 14, configure terminal, we go on the interface E0/3, and the command is spanning tree for VLAN 10. What's the command? Port priority. Port priority, and the increment can be of 64, right? So we can do 32. So let's do 64. 64. Save. So VLAN, that port has been made very attractive for VLAN 10. So let's wait a while. Then we come on switch 18 to check whether E0/1, this one is enabled for VLAN 10 traffic to pass. Let's check again. E0/1. Let's check again. Let's wait for a while. So now let's check on switch 18 again to see whether it has changed. Show spanning tree for VLAN 10. And E0/1 is still blocking. All right, what's the comment? Let's check to see whether the changes took effect on switch 14. On switch 14, we lowered the port cost. Show spanning tree for VLAN 10. We lowered the port cost on this interface. All right. 32, 64, sorry, but it didn't take any effect. It didn't take any effect. Let me do it once again. So configure terminal. Interface E 0/3 spanning tree for VLAN 10. Port priority, let's make it 0. Verify show spanning tree for VLAN 10. The changes didn't take effect. I think it's coming from a simulator because the change has to take effect. Maybe this simulator doesn't permit me to change the priority. All right, so let's try to see if we can alter the port cost here instead of the interface priority. So let's lower the port cost to something like 20,000 on switch 14. So configure terminal. Interface E 03 spanning tree for VLAN 10 and the cost. So 20. Let's say check show spanning tree for VLAN 10. It didn't change. I'm sure the simulator is not allowing me to change the port cost on the interfaces because, as a matter of fact, it should change. If it be well switches, it should change. I'm using EVNG, and I'm wondering why. Okay, so the bottom line is you either change the port cost on this interface to be low, or you change the interface priority, as you just saw. Once you're able to do that on live stream, once you're able to do that, the port here will open for VLAN 10 to pass. Yeah, I'm sure I'm limited. My simulator is limiting me. All right, so now let's verify the path for the VLAN 20 traffic. So we are starting from here, VLAN 20 PC. We are starting from here on this switch 9 here to see where the VLAN 20 traffic is passing. Is it using this link or this link? Obviously, to use this link because, as we explained earlier on, this interface is very attractive for every VLAN on this non-MST region. So, irrespective of which VLAN is configured on, it's going to use this port here. But if that happens, it means every VLAN is going to use this traffic. That's going to create congestion on this link. So we want VLAN 20 traffic to be diverted here. But first, let's check to see on switch 9 to see where VLAN 20 is passing. Switch 9. And the command is show spanning tree for VLAN 20. E00 is the root, as we all predicted, and E01 is blocking VLAN 20. So how do we make E01 attractive for VLAN 20? How do we make this port here attractive for VLAN 20 to use it? By lowering the port cost on this interface. I think, again, the simulator will not permit me that. Let's try. So on this interface, I'll lower the port cost for VLAN 20. For VLAN 20. Okay, so we go on switch 9 and on E0/1, port cost will be lowered. First, let's check the port cost on that interface. Switch 9. Show spanning tree for VLAN 20. And the port cost on E0/1 is 100. Let's see if we can lower it. I hope it works this time. 20. And E0/1. The spanning tree for VLAN 20. Cost. Let's make it 4. Save. Verify. Show spanning tree for VLAN 20. It worked. It worked. So I think it's working for rapid spanning tree environment, but it's not working for MST environment, as in the altering of the port cost. That's fine. So instantly, you see that VLAN 20 is preferring E0/1. That is a root. Right now, we have created load balancing on switch 9. If you look at the VLAN parameters for VLAN 10, watch. VLAN 10 is preferring, on the same switch 9, VLAN 10 is preferring E0/0 as the root and blocking E01 for VLAN 10. However, E01 is forwarding for VLAN 20 and also E00 is blocking for VLAN 10. So we have achieved our purpose. Over here, VLAN 20, we have managed to change the port cost on this interface as well. So now it's forwarding VLAN 20. So VLAN 20 is coming this way, and VLAN 10 is going this direction. That is perfect. What happens on this switch? Let's see where VLAN 20 is passing. Is it here? Is it here? Or here? Let's check. On switch 15. Switch. Enable. Show spanning tree for VLAN 20. And watch here, VLAN 20 is running on MST20, and that is the root for VLAN 20. We did that configuration. So if that is the root, then every port will be designated for VLAN 20. So every port is forwarding the VLAN 20 traffic. What does it mean? It means VLAN 20 can either go through here, here, or here. But will it be allowed on this port here? We prefer it to go through this link here. That is what it's been tasked to do. So we go on switch 14 to verify whether this port E0/0 is the root for VLAN 20. If that is the root, then perfect. You're on the right path. So switch 14. Show spanning tree for VLAN 20. Where is the root? Yes. So E00 is the root for VLAN 20 traffic and it's forwarding. So we are on the right path. VLAN 20 is now passing here. What if it gets on this switch? You see, because you are not able to alter the port cost on these switches in the MST region, it's going to be difficult. But as I said earlier on, you have to lower the port cost on this one for VLAN 10 for it to open this port here for VLAN 10 on switch 18. The same way, for VLAN 20, you lower the port cost here. But since we can't do that on my simulator, I think the lab is done. You can try it on live switches and it will work perfectly for you. Thank you all for coming. And please stay tuned for more labs from AfriLink Network Consult. As our slogan goes, become the best by learning from the best. Thank you.